Well, thanks for coming today. My name is Scott Miller. I'm an aquatic ecologist with the BLM and Utah State University. I direct the BLM's National Aquatic Monitoring Center, and our group is leading the development of the aquatic component of AIM. And so I'd like to take a brief hiatus from terrestrial ecosystems and present to you the first of 3 aquatics talks today. Specifically, talk kind of like Sherm just presented on the condition of our streams and rivers occurring on the national system of public lands in the contiguous United States. So we've heard a lot about this, and I thank the previous presenters for allowing me to fly through the intro and get to the meat of the talk, that under the Federal Land Management Policy Act, we need to manage the national system of public lands under a multiple use mandate. At the same time, we need to protect the long-term health. Not only is this relevant and stipulated by FLPMA, but also the Clean Water Act. And so, having information regarding the condition and trend of aquatic resources, in this case streams and rivers, is critical to carrying out our multiple use mandate and ensuring the sustainability of those practices. We're also, again, held to it by the Clean Water Act. We're going to hear a variety of example talks today about how assessment and monitoring data is being used to inform management. These are going to go all the way down from the permit renewal. I have Grand Staircase Escalante National Monument here and the allotments in that monument presented here. We have lots of questions at the grazing allotment level, at the monument level, at the level that we're developing RMPs, whether it's a monument, a field office, a district. We also want to know, though, about the cumulative effectiveness of our management action, so that we do statewide reporting and things like the public land statistics. Increasingly low because of invasive species, fire, climate change, endangered species, we're starting to look beyond traditional geopolitical boundaries and think about things like ecoregions or whatever the polygon happens to be, but it's not our traditional reporting units. And ultimately, we have questions nationally. And so although this kind of myriad of resource management questions or challenges is quite varied, as Sherm presented and others, they do have a common thread, and the common thread is the fundamentals of land health. And when we think about aquatic systems, the BLM defines aquatic integrity by geomorphic function, water quality, species and habitats in riparian areas, and it's at that nexus of what we're trying to manage for. These systems that are in proper functioning condition and giving us the ecosystem services that we desire from them. So I'm going to present to you an example of bureau-wide reporting. But I'd encourage you to come back at 10:40 today. Justin Jimenez is going to give a talk that operates at the interface of kind of district, state, and all the way down to how we're taking the same data collection and doing it at a very local scale to inform determination or understandings of the causal factors contributing to departures from the conditions we seek to manage for. So under AIM, in March is going to come out a tech note on the National Aquatic Monitoring Framework. This outlines the BLM's game plan of how we are going to systematically monitor, assess, and monitor aquatic resources. We're starting with streams and rivers. So this is a comprehensive approach. It has pulled together the Soil, Water, and Air Program, the Fisheries Program within the BLM, and the Riparian Program, as well as others. The challenge I want to present to you today is how we apply land health at a scale of over 100,000 perennial stream kilometers. It's a lot of inference space. And again, we are using these AIM principles, and it's going to allow us to make inference not to our sampled sites, but the entire population of BLM streams and rivers. We've heard a lot about this, so I'm going to move on. So what is the BLM's Western Rivers and Streams Assessment? This is the first ever West-wide reporting of the condition of BLM streams and rivers. It's a collaboration between the BLM and the EPA. The EPA has the National Aquatic Resource Surveys, or NARS, where every 5 years they assess lakes, streams, wetlands, and intertidal zones. We're collaborating with them on streams and rivers. We have a relatively simple question. What % of these streams and rivers have minimal, moderate, or significant departure from reference for indicators that can speak to these land health fundamentals? Now, when we look at a lot of the streams, the waterways on public lands under the Clean Water Act, the beneficial use of those systems is the protection and support of aquatic life. And so one of the things we want to ask is, if we have excessive thermal, sediment, or nutrient loading, what risk does that pose to the biota? Because ultimately, that's what we're trying to manage these systems for, from a conservation standpoint. After this initial effort, we will assess trend through time. I'm presenting preliminary results on only 2 of the 3 years of data today. So very preliminary results, no trend at this time. So how do we do this? We use the National Hydrography Data Set to identify all the streams and rivers occurring on BLM land. These are the small creeks occurring in the headwaters all the way to the Green River that's draining a large proportion of BLM lands. We use the probability-based sample design, wanted to spatially balance, to sample over 300 points on BLM lands. EPA is concurrently doing this, and we're going to be able to take over 50 EPA points that are also on BLM lands and use them. And I said we stratified by level 3 ecoregion. This isn't really a stratification. It's just the beginning of a reporting unit, kind of like we've heard in the previous talk. These are the, because this is our first effort and our sample sizes are low, these are 7 aggregate ecoregions that we're going to be presenting on: Pacific Northwest, Northern Rockies, Northern Arid regions, Southern Xeric regions, etc. So what did we measure? Under the BLM's National Aquatic Monitoring Framework, we have developed core indicators. These core indicators relate to our land health fundamentals, so things like water quality and looking at salinity, total nitrogen, total phosphorus. These are things we have committed to meeting state water quality standards. Attributes that characterize geomorphic form and function, so things like residual pool depth, the size of particles that you have in the stream bed, large woody debris, etc., as well as biotic components, using macroinvertebrates as an indicator of biological integrity, using ocular estimates of riparian vegetative cover and structure, and canopy cover. I should note that the methods for all of these are concordant with existing either BLM, Forest Service, or EPA monitoring protocol. We did not create anything new. We're applying existing methodologies, which is going to allow us to leverage a tremendous amount of data, and most importantly, how to interpret this data. So Eric Archer, following up on me, is going to give a whole talk on how we establish condition. In aquatics, we don't use ecological sites right now, and no other agencies for water quality that are using the ecological site concept. Rather, recognize because of the Clean Water Act and its legacy, state agencies, EPA, USGS, have established over 1,000 reference sites throughout the western United States. We can use these reference sites and different models that have been developed to understand minimal or significant departure from reference after accounting for natural environmental gradients. That is the crux with all of our monitoring. There's tremendous spatial heterogeneity on the landscape. How do we partition natural spatial variability from that caused by anthropogenic activity? And so I'm going to show a series of figures that talk about if this is the range of conditions we can classify sites that fall as significant departure, moderate, or minimal. So I'm going to show a series of graphs that look like this. This is percent of stream kilometers, not the percent of sites sampled, the percent of BLM stream kilometers throughout the contiguous western United States that have minimal, moderate, or significant departure, plus or minus 90% confidence intervals. So lots of indicators, lots of geographic terrain to cover, can't do it all. So I'm going to present you results from 5 hybrid ecoregions that we have data for right now. Pacific Northwest, Northern Rockies, Northern Xeric, Eastern Xeric, and Southern Xeric regions, very similar to the ecoregions Sherm was just presenting on. Right now, all states in the U.S. are using aquatic macroinvertebrates as the primary indicator of not just biological condition, but water quality and physical habitat. So this is one of our core indicators. What the results show is for the Pacific Northwest and the Northern Rockies, a large majority of BLM streams, over 50%, have minimal departure from reference. If we go to some of the Xeric regions, the Xeric North all the way to the Xeric South, we see anywhere from 50 to 80% of BLM stream kilometers as potential significant departure from reference. Interestingly, Sherm showed us where some of the greatest kind of red flags are in these southern and eastern Xeric regions. It's the same place where we're seeing some degraded conditions. An example of a water quality indicator, this is salinity. This is the amount of calcium, sodium, magnesium, chloride in the water. After accounting for natural spatial variability, things like Mako shale and that contribute salinity to streams, we can look at what's left over. Again, for the Pacific Northwest, we have a very small proportion, less than 17% with significant departure. But when we look to the northern Rockies and some of the arid regions, we see a large proportion of BLM streams, all the way up to 68% having excessive salinity. I want to stress this is a one-time snapshot. We could never use this data for a 303B listing under the Clean Water Act. That is not the intention of this sampling. The intention of sampling at this scale is to identify priority stressors for the BLM to start paying more attention to. For example, a highlight of my talk is going to be water quality is potentially a much bigger issue than we're giving credence to right now. Stream canopy cover. So we're concerned about stream canopy cover because of all those critters that we're trying to protect in the streams. We want to reduce incoming solar radiation, so we want shade. We want to reduce the threat to predation to those amphibians, the fishes, so we want cover. Stream canopy cover, we've been focusing a lot on riparian areas. The weight of evidence suggests we've had a big impact. If we look from the Pacific Northwest all the way to the eastern xeric region, you know, anywhere from 60 to 80% of stream kilometers aren't showing much departure in terms of canopy cover. We do have some hot spots, northern xeric region, southern xeric region, almost 30% with less canopy cover than we'd expect. The last indicator I want to share with you is stream habitat complexity. How much large woody debris do we have in streams? How many boulders, overhanging banks? Again, this is habitat that supports aquatic life. We go from the Pacific Northwest where we have our first 0%. Everything's either in minimal or moderate departure from reference, to, again, some of our hotspots of the eastern xeric region, the southern xeric region, where we have 20 to 40% of stream kilometers with less structural heterogeneity than we like. They start to look like this, where there's not a boulder, an iota of shade, an undercut bank, or anything to protect the aquatic life. And the models that we're using that Eric's going to talk a lot more about suggest that they should have that structure there. So there's a lot of indicators. So one of the things we can do is we can take all the indicators that we look at, from water quality to biological condition to embeddedness, which is basically the amount of fine sediment surrounding that matrix of larger particles in the stream, and we can rate the indicators west-wide from those with the most significant departure to the least. And as I highlighted, water quality and biological condition top out the list, whereas some of our riparian conditions and our stream geomorphology is ranking out lower. But those are national averages. And so we're averaging lots of points across lots of space. If we look at this by just two example regions, the northern xeric and southern xeric, we see that in the northern xeric, again, degraded biological condition, potential issues with water quality, with nutrient loading are some red flags, but they don't have near the issues with conductivity, not many habitat issues. We go down to the southern xeric, we have all the water quality issues, but we're also seeing more issues with canopy cover, in-stream habitat complexity, embeddedness, so multiple stressors or potential stressors occurring at these sites. So I talked about the Clean Water Act and how we have focused a lot on chemical, physical, and biological conditions. Those are the mandates of the Clean Water Act. And we haven't focused near as much on biological conditions for a while, or physical habitat. It's been water quality for a long time. And one of the things we want to do is assess the relative risk or the implications of a given stressor occurring, excessive thermal, sediment, or nutrient loading for the biota. This is just like when you go to the doctor. They ask you, do you have a history of heart disease in your family? Why are they asking you that? Because if you do, your probability of having heart disease is increased. That's the question we're asking. So we're looking at what are called conditional probabilities. So we look at what is the probability of poor biological condition given poor sediment condition versus the probability of poor biological condition given good sediment condition. So for anybody associated with confusion matrices or contingency tables, that's all this is. This is concordance. We had 600 kilometers in poor biological conditions, 600 kilometers in poor sediment conditions. They agreed. versus discordance, where we have poor biological conditions but good sediment. In the end, we can make statements like, if you have significant departure for sediment, we're 1.5 times more likely to have degraded biological conditions. We can use very complex models to answer this question, but I think this puts it in kind of common terms that people can relate to. So I'm going to share with you a national perspective of those same relative extent figures. This is the percent stream kilometers having significant departure from reference for the stressors. Now over here, I have a paired figure for relative risk. And I apologize, you can't see the dashed line all that well, but that's 1. And then we have 90% confidence intervals. If the confidence intervals do not overlap 1, that stressor has a significant impact or is associated with degraded biological conditions. So we can look at our water quality impacts. That's the salinity, nitrogen, and phosphorus. They're pretty ubiquitous across BLM streams and rivers. When present, you're anywhere from 1.5 to 1.8 times more likely to have degraded biological conditions. In contrast, we have things like in-stream habitat complexity and embeddedness that aren't that ubiquitous on the landscape. But when present, you're up to over 2 times more likely to have degraded biological conditions. This is an example of more localized impacts. A quick plug. This is not all doom and gloom, okay? Justin Jimenez is going to give a talk from Utah. It's where we got over 80% of stream kilometers have an excessive salinity in some field offices. But we're able to show it's a multiple use matrix. We're inheriting a lot of water quality problems from other land uses, other landowners. So just in case anybody's about to get depressed and run out of the building, stick around. Again, we can look across regions and see that how the biota is impacted by these stressors, and that, you know, in-stream habitat complexity, for example, down in the southern Xeric region where we have 40% of streams with potentially simplified stream channels, you're 2.5 times likely to have degraded biological conditions. So this is having a real impact on the beneficial uses that we're trying to manage for. So in summary, first of all, this is only 2 years out of 3 years of data, so all of these estimates could change. We have another 100 points to collect. We are seeing that almost half of BLM streams and rivers, so again, this is weightable and non-weightable streams, have excessive salinity and nutrients and potentially degraded biological conditions. But there's a lot of investigation to be done to understand why that is. We see less impacts with riparian and in-stream habitat complexity. But what concerns me is this idea that over almost 30% of streams, those stressors are present and they're having adverse impacts on the biota. So we've heard a lot about national level reporting. So I just want to come back with this idea of repurposing our data. In the state of Nevada alone, the Western Rivers and Streams Assessment has 48 points. The Nevada Department of Environmental Protection has an additional 58 points on BLM lands. So with only adding about 30 points, the state of Nevada is going to be able to do field office and district level reporting and pay for about a third of those samples. We use methods that are compatible with state and federal agencies. We use a statistically valid sample design that allows us to repurpose these points. And so this is where, yes, these are not adequate point density for grazing permit renewals, but it helps get us closer. And if we want to intensify in areas that we think are a significant concern or of high resource value, we can step this down further and add more points in a particular area. So in conclusion, some of the next steps. The National Aquatic Monitoring Framework is kind of in its infancy compared to the terrestrial effort. We've been up and running for about 3 years now, but these are some of our first big projects. The Western Rivers and Streams Assessment will be completed in 2015. It'll be repeated in 3 to 5 years with the EPA to assess trend. We have a tech note that should be coming out in March of 2015, a tech reference late in 15 or early 16. And this is a map from the North Slope of Alaska to the western United States down the Grand Staircase, that we have projects occurring at all scales. And over a 3-year period, we should have over 800 aquatic data points collected for the BLM following this framework. So with that, I will take any questions. Yeah. So some
sounds like an outstanding protocol to understand the general conditions across the scale that you're interested in until you get to the local scale. At the local scale of the watershed of the allotment level, in order to actually manage for improvement of the conditions that you highlighted here, I would use the integrated riparian management protocol that is embedded in the Lori Dickert et al. That is about now. We're using assessment of functional riparian conditions to identify the at-risk locations and what is driving the risk, and then manage for that and monitor your success using a protocol like MEM. How are these data intended to dam with that approach?
So to repeat the question, how does PFC and local assessments interact with the BLM's aquatic core indicators? There's a lot of different ways we could answer that. And I think that the BLM has a lot of tools in our toolbox, and they're very complementary tools. I frankly think we should flip the paradigm on its head. I think that the BLM started out with an assessment technique, and we never moved beyond that assessment technique. We stopped at PFC. PFC is a great tool. I think an approach like this, as Justin's going to show in the state of Utah, we don't know where the problems are, and the best way to detect where the problems are is a statistically valid sampling framework that is unbiased. Once we identify where the problems are, we need to figure out, we don't need to measure every one of these indicators once you get down to the site scale. We need to measure those that are showing departure from reference, violations of our land health standards. The benefit of PFC is to get the permittee or the landowner or whoever, whatever the use is out there on the landscape, the recreationist, to understand the source of that problem. They don't understand data like this. They're going to glaze over and laugh me out the room. So I actually think we'd get a lot more strength if we flipped our paradigm around. Use this to identify priority stressors. Use things like PFC to help identify the source of degradation while recognizing, though, that PFC is limited. If we have water quality issues, PFC is only going to partially help, right? Well, we can follow up afterwards more. But I'll pass it on to next speakers.